Hi, mister. Okay. These are my video problems. We are going to start with number 1. Fx equals 3x squared plus 4x. We are going to solve this problem and find the derivative by using the definition of a limit, which would come out being limit as h approaches 0, 3 parentheses x plus h squared plus 4 parentheses x plus h minus parentheses the original fx problem, which would be 3x squared plus 4h divided by h. We start after we fill in. We start by solving x plus h squared, which would be x squared plus 2xh plus h squared. Remember to put the 3. We can't forget that over there at front. After that, it's plus. We solve 4 parentheses x plus h, which will come out being plus 4x plus 4h. We distribute the 4, as you can see. And then we distribute the negative sign at 3x squared plus 4x, which would be minus 3x squared minus 4x divided by h. After we have that over here, we distribute the 3 here, and it would be 3x squared plus 6h plus 3h squared. The rest stays the same. Now, to facilitate our problems, we eliminate the ones we can from here. 3x squared minus 3x squared, see? And 4x minus 4x. This would come out being 6xh plus 3h squared plus 4h divided by h. So now, if you take the h out, see? And it would come out being 6x plus 3h plus 4, because since we took the h out, we can eliminate it by dividing that h over there, see? And since h approaches 0, it would be 3 times 0, so that would be 0, and it would come out being 6x plus 4. That is our final answer. We're going to move to problem number 2 over here. Problem number 2 is fx equals 3x7 plus 3x cubed plus 2. We are going to solve this problem by using the sum rule. This would come out being, after we substitute, well, not substitute, after we put in the d over dx, that's all we do. See? We put d over dx at front. And now is when we do the thing. We separate. It would be d over dx 3x7 plus d over dx 3x cubed plus d over dx 2. See? And then we would have to put this 3 before the d over dx, x7. We move the number at front, which is 3 again, before d over dx, which would be 3d over dx x cubed plus 0, because this would be like rule number 1, see? It equals 0. And then we have 3 from this 3 over here, and times 7x6, because we move from x7, we move the 7, we multiply it. 7 times 1, because 1 is the number before x, the invisible number, and the exponent here would be 7 minus 1, which is 6. So that's why x7 comes out being 7x6 plus 3, because this is the number we have here. And then just like before, we multiply 3 times 1, the invisible number before x. And then the exponent would be 3 minus 1, which would be 2. See? 3x squared. This is what we get up to now. 3 times 7x6 plus 3 times 3x squared. And then we multiply 3 times 7x6, which gives us 21x6 plus 9x squared, product of 3 times 3x squared. This is our final answer. Problem number 3. Here it is. Problem number 3. Let me. So confusing. Problem number 3. Fx equals parentheses x squared plus 3 parentheses to the 8th power. We are going to use the generalized power rule. D over dx before the original function, which would be x squared plus 3, parentheses on both sides, to the 8th. This is how we do it. We move the 8 up front, parentheses x squared plus 3, parentheses, what's inside the parentheses stays the same, and then the exponent, 8 minus 1, like before, remember? Times the first number here, which would be the invisible 1. See? And then it comes out being 8 parentheses x squared plus 3 to the 7th power. That is our final answer. Number 4. Number 4 is fx equals negative 2 sine x. We are going to use rule number 7 here, which would be d over dx, parentheses negative 2 sine x. Original function, remember? This is how we do it. Very simple. We move the first number, the number before sine x, negative 2, we move it before d over dx. Sine x stays the same. Now, rule number 7 clearly states that d over dx, sine x, is the same as cos x. See? This is why this over here comes out being negative 2 cos x. And last but not least, number 5. Fx equals parentheses 3x plus 4 cubed times x squared minus 1. We're going to use the product rule here. Bracket d over dx parentheses 3x plus 4 parentheses cubed. That is the first expression, goes there. And then you multiply times the second expression. That is the first part. Now, the second part, we use the add sign, and we take the first expression, see, 3x plus 4 cubed, and we use the d over dx for the second expression, x squared minus 1. See, that is there from the output. Now, zooming in, this over here comes out being this. We take the exponent, we move it up front, 3, parentheses, 3x plus 4, squared, y2, because 3 minus 1 equals 2 for the exponent. And then we multiply the first number here, the first number before the x, which is not invisible anymore. It's not 1, it's 3, see, it's 3. That's what we have here. Now, x squared minus 1 stays the same, plus, now here, as you can see, we can leave it like that, or we can use the generalized power rule we used for this little part over here, and do the same thing, see? And then d over dx, x squared minus 1, comes out being 2x. Why? We use it like separating. It would be d over dx, x squared, minus d over dx1. So d over dx, x squared, 2, we move it up front, into minus 1, 2x. And since 1, for the 1, we can use it for the constant rule, which would be rule number 1. It comes out being 0. That is why this ends being up only this, 2x. After that, we take the 3 and we multiply it times this 3, 9, parentheses 3x plus 4, parentheses squared. See? And then this stays the same. This first part, see? This x squared minus 1 stays the same. Plus what we did over there. 3 times 3, 9. 9 parentheses 3x plus 4 parentheses squared. And then the 2x stays the same. You can go further, but like you said, I could leave it up till there. So that's it. Those are my problems. And Merry Christmas, mister. Happy holidays.